Hello, we are going to start with section 11-4 today. And 11-4 is our start into the topic of probability. In our probability portion, we have a couple of different types of probability. We've got what's known as theoretical probability, and that's the most common probability because it deals with what will happen or what could happen. For example, this probability is used with coin toss or dice, okay, to determine the odds are part of it also, but determining the probability of, let's just say, what's the probability when I toss a coin of getting tails? And we write it like that with a little p, and the event that we are talking about, we write inside of here. Okay. And you all know this, the probability of tails when you toss a fair coin is 1/2, or 0.5 is a decimal. Okay. What you will hear me talk about numerous times when I'm talking about probability is this statement right here, though. I always think of probability simplistically as not whale, as the part over the whole. Okay. And the reason why I think about this is because you can always track back to this. The whole is all the things that can happen. And the part is specific things, like when we're talking about our example with the tossing the tails. Okay, you can either toss tails or heads. There are two things that can happen in total. But when I'm talking about the specific thing, tails, there's only one way to get tails, and that's that. And that's why the part over the whole is 1/2, which is what we stated over here. So let's go down to our first example. A die is rolled once. A die is one of a six-sided cube. Find the probability of rolling a 3. Well, how many different things can happen? That is the whole. I can either roll at 1, 2, 3, 4, 5, or 6. There are 6 possible things that can happen. There is only one way to roll a 3, so the probability of rolling a 3 is 1 out of 6. The next one, part B, the probability of an even number. Well, my whole is still 6 because there's 6 things that can happen. But when I'm talking about the probability of rolling an even number, I've got 2, 4, and 6. I've got 3 even numbers out of 6. So the probability of that is 1/2. Okay. The probability of rolling a number that is less than 5. That's how we abbreviate less than, by the way. That's the symbol for less than, so I don't have to write less than 5 out. Okay, the numbers that are less than 5 are 1, 2, 3, and 4. There are 4 of them out of 6. And remember, you have to write your fractions in simplified form. And right now, I'm going to show you a trick on your calculators that will help you out with this, especially as you get into bigger numbers. Okay, 4 out of 6, 2 goes into both of those, 2 goes into 4 twice, and into 6 3 times. So that was dumb. 3. So the probability of drawing a number that is less than 5 is 2/3. But I'm going to call up my calculator here again, and I'm going to go into this. Let's say I have a fraction like 24 over 36, and I want to know what that is as a simplified fraction. If I put it into my calculator like this, 24 divided by 36, and press enter, it's going to give me a decimal answer. When I look at that, 0.6 repeating is what that is. It cuts off the last number is 7 because it rounds up. That is actually 0.6 repeating. It goes on forever. But if I press the math button right here, and then you see the very first option says FRAC or fraction. If I press 1, it takes the answer from above, the 0.6 repeating, and it's going to change it to a fraction. I just press enter, and it gives me the simplified fraction of that 2/3. Okay, I will do this a couple times just to help you to get through that, but that is the way to change any decimal to a fraction, like 142 divided by 250. When I do that, I get this decimal answer. I want it as a fraction. All I have to do is press math, enter, enter, and it gives me the simplified fraction. Okay, that's a little helpful hint for dealing with the calculators that you have. Okay, so now we're on to example D. We want a number that is less than 10. Okay, all of the numbers on a die are less than 10. There are 6 of them, 6 out of 6. So the probability of rolling a number that is less than 10 is 1, or 100% of the time you will get a number less than 10. Okay, and then the probability of getting a number that is greater than 6, there are no numbers that are greater than 6 on a die, so it's 0 out of 6, or 0. The part over the whole. You are dealt 1 card from a standard 52 card deck. Only 1 card. Find the probability of being dealt a king. Well, the probability of being dealt a king. The first thing we have to do is talk about the whole. We always want the whole first. There are 52 cards that can be drawn. That is my bottom. Okay. How many kings are there? There's the king of hearts, the king of diamonds, the king of spades, which I'm terrible at drawing spades, and the king of clubs. And so I've got 4 different kings in the deck. That is my part, 4 out of 52. Grab my calculator. Remember, divide is fractions. 4 divide 52. It's going to come up as a decimal. And then I go math, enter, enter. 1 out of 13 is the probability of drawing a king. That is simplified form. What about the probability of drawing a heart? Well, in a deck of cards, if you are not familiar with cards, you have hearts, and I'm going to get rid of the king part now. And there are 13 hearts, there are 13 diamonds, there are 13 spades, and there are 13 clubs. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, king, queen, jack, queen, king. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 cards. So when I'm talking about the probability of drawing a heart, I have 13 out of 52. 52, I don't know why I wrote 15. 13 out of 52, but we can also come back over here and say, hey, there are only 4, and there are only 4 suits, and only one of them is hearts. 13 out of 52 reduces to, or simplifies to, 1/4. And the probability of drawing the king of hearts. The probability of drawing a king of hearts. Probability of king, well, my hole is still 52. There is only one king of heart in the deck. The odds of drawing it is 1 out of 52. And that is simplified. That is the final answer. Okay, so let's talk about empirical probability. That's the next thing. Now, theoretical probability, I said at the start, was what could happen. Empirical probability is experimental. Instead of what could happen, it's what did happen in an experiment that we did. Still talking about the part, though, over the whole. So I have this diagram here that has the marital status of the U.S. population ages 15 or older in 2020 in millions. Male that are married is 68. Male that are never married is 46 million. Divorced is 11 million. Widowed is 3 million. And the total of males is 128 million. Likewise, with the female, it goes across. You just read married from the top column, female from the row, married females, there's 69 million, so on and so forth. So the total number of married people is adding the male and female together. There's 137 married people in the 137 million. Okay. So we use this table here to build our little probability idea. Okay. So I'm going to go down to my example here. If one person is randomly selected from the population described in that table, find the probability to the nearest hundredth. Now, notice that's to the nearest hundredth, so we're talking about decimals, okay, that the person is divorced, okay? So one person out of the population, the total population is right there, 264. How many divorced people are there in the population? There's 26 million. So the probability of a divorce is 26 out of 264. I grab my calculator, 26 divided by 264. Enter, and it says 0.0984. I'm writing it out like that because I forgot when I wisdom what it said to round to. It says to round to the nearest hundredth, which is this place. So I look 1 to the right is 8. Since it's 5 or more, I add 1 to this. When I add 1 to 9, it makes it 10. So it is 0.10 or 0.1. That's the probability from right here. Now, what's the probability if the person is a female? Well, again, we're talking about the total population. So 264 is my whole. And then how many of those people are female? 136 of them. And then I grab my calculator again. The calculator is coming in huge. 136 divided by 264 is 0.51515. Okay, rounded to the nearest hundredth is 0.52. And that's it. The part over the whole. And that's how easy probability is. Have a good one.